Hey guys, this is part two. I'm going to do the same thing I did in part one, which is I'll put the number of the problem I'm working on at the top left corner. So we're starting with number 19 in part two. So if you need to just skip ahead to a certain question, just skip ahead and look at that number at the top. But of course, I'm going to work out all of them because I don't know necessarily which problems you're going to need help with. So let's get started with number 19. Number 19, we have log base 2 of 1 minus x equals 4. Now, you have to diagnose or recognize this problem as a logarithm problem. It's pretty obvious because it says log in it. The second thing you want to point out is that you want to make sure that, there's no other logs in this problem. It's just this logarithm, right? This is just one logarithm and it equals 4. The reason I say that is because sometimes you have problems with more than one logarithm. You need to combine them, but not in this case. We have a single logarithm. Now, let me explain some mistakes real quick before I do this. Now, this is all one logarithm, okay? It's not log 2 times this. A lot of times I see people trying to divide by a log 2. No, that's not at all what's going to happen here because this 2 is just a part of that log. It's the base number. That is all one collective thing there. Another thing I see people do is they put log on this side. They try to make this a log 2 of 4 as well, instead of just leaving it as 4. You can't do that because the problem is set up this way. So if you just add log base 2 to the other side with the 4, if you put logarithm on that side, then you're changing the equation's value because, again, whatever you do to the left side has to be done to the right side. And this is the way the problem came to us. So when you see your logarithm, this is what you should do. Take your logarithm and put it into exponential equation form. Now, if you're wondering what I mean by that, you might want to go back and check part 1 because it's the same thing you did in part 1 on numbers 7 through 10. 7 through 10 on part 1, you had a logarithm, you put it in exponential equation form. We're doing the exact same thing here. So if you do that, you're going to have this 2 as the base of the exponent form. 4 will be the exponent for it, 2 to the 4th power. And then 1 minus x is what this is equal to. So now you've converted your logarithm into exponential equation, and now you can solve it because 2 to the 4th power is a number. 2 to the 4th power is 16. So really we just have 16 equals to 1 minus x. So it's a very simple equation. We can subtract 1. We're subtracting 1, by the way, because it's a positive 1. I know you see the minus sign on x, but that's the minus sign on x, not on 1. So it's a positive 1, so we're going to subtract it. So we have 16 minus 1 is 15 equal to negative x, which means x is equal to negative 15. But the main thing that you need to keep in mind here is that first step. When you have your logarithm, just a regular plain logarithm, you need to put it in exponential equation form because once it's there, it's relatively straightforward. Number 20. So this is the second type of problem. This is an exponential equation problem. We have 9 to the x plus 7 power equals 81 to the 2x plus 5 power. So exponential equation problem, you're going to work out in 3 steps. Step 1 is to log both sides. So we're going to do this to both sides. We're going to put log on the left. We're going to put log on the right. As long as we do it to both sides, right, then we're good. So we're still going to have the same equations. Still going to be 9 to the x plus 7 power, but it's still going to have a log in front of it. And it's still going to be 81 to the 2x plus 5 power, which is going to have log in front of it. And what that lets us do, what that lets us do is we're going to be able to move these exponents to the front. Move exponents to front. And it's just the exponents, not the 9, not the 81, only the exponents. X plus 7 get moved up here, so it'll be x plus 7. I'm going to put it in parentheses because there are 2 pieces, right? X plus 7 is 2 different pieces. I want to make sure I remember that they go together. Log 9 equal to, and then we're going to move this exponent, 2x plus 5, to the front of this log. So we're going to have the 2x plus 5 up front, and it's going to be times log 81. Now keep in mind that this is multiplication. It's 2x times 5, or 2x plus 5 times the log 81, and x plus 7 times the log 9. And that brings us to step 3. Because we're multiplying those with the logs, if we want to cancel the logs, we want to divide them on both sides. Now, in this case, I have x values on both sides of the equation. So it doesn't really matter if I divide both sides by the log of 9 or the log of 81. But typically, it's easier if we divide by the smaller version. So if I divide by the log 9 on both sides, then on the left side, it cancels out completely. On the left side, it's just going to leave x plus 7. On the right side, it's a little different because the log 81 divided by the log 9 is a number. What number is it? Well, we can go to our calculator and we can find out. So type in log 81. Make sure you close your parenthesis there, because if you don't, you're going to end up typing it in wrong. Divided by the log 9. And we get 2. So let's go back to this. So this whole thing here, this is equal to 2. Now this is being multiplied, remember, to 2x plus 5. So this 2 is also being multiplied to 2x plus 5. It's just this log stuff turned into 2, as the calculator says. So now it's kind of a normal equation. If you're okay, I'm just going to sort of erase what I have here and just focus on this. You guys are more than welcome to rewind the video if you need to. So give me a second so I can rewrite this problem down. I really don't need the parentheses on the x plus 7, but so we're going to distribute the 2 because we're multiplying the 2 with 2x and 5. So we're going to distribute. That'll make this 4x plus 10 equal to the x plus 7. And we're just going to combine our x terms. So I'm going to focus on moving this x term over. You can do it kind of either way. It doesn't really matter. As long as you can keep up with your terms and combine them correctly, you shouldn't have any issues. So this makes the equation 7 equal to 3x plus 10. So then we'll subtract 10, so we can get rid of that. We'll have negative 3 equal to 3x. So when I divide by this 3 to cancel it out, I get x equal to negative 1. All right, let's move on to number 21. So number 21, we have log 9, negative 11x plus 2 equal to log 9 of x squared plus 30. Now, the thing about this one is we have just a plain logarithm. Again, this is just all one logarithm on the left and just one logarithm on the right. I'm not adding or subtracting anything after the log. It's just plain log equals a plain log. The reason that's useful is because if this log is equal to this one, then that means that the components within the logs must be equal to each other, right? If this number ultimately ends up being like 13, then this number would also have to be 13. So those two things have to be equivalent. Negative 11x plus 2 has to be equivalent to the x squared plus 30. So I'm basically kind of ignoring these logs. I normally wouldn't do that, but I can on this problem because this problem, like I said, is just a logarithm equal to a logarithm. There's nothing fancy going on. There's no other math involved. It's just a log equaling a log. So that means the components within them must be equal as well. So now I'm just going to kind of combine terms and move things around. So if I subtract 2 and combine it with 30, that'll leave me negative 11x equal to x squared. 30 minus 2 is 28, so plus 28. Now, I'm also going to move the 11x over here, and I'll explain why afterwards. Now, negative 11x, to move it, I would have to add the 11x. So that leaves me 0 equal to, well, let me put it over here, x squared plus 11x plus 28. 11x doesn't combine with anything because there's no other x term on that side. So it just sort of fits in the problem. It can't combine with x squared because it's not a like term with x squared. It can't combine with 28 because it's not a like term. What we have is a quadratic. And we can solve this quadratic in our calculator. Now, I'm not sure if my calculator has the program already on it. No, it doesn't. Your calculator should have that program, though, where you can go in and factor it and solve it. So you go to the program button, you would see factor on that list, and then you can just type in the A, the B, and the C's. I'm just going to go ahead and spit out the factored version of this. So this factors into x plus 4 and x plus 7. But don't forget, those are not the answers. What this tells us is that x plus 4 is equal to 0 and x plus 7 is equal to 0. So if you actually solve for the x's, right, you find that x is equal to -4 and x is equal to -7. And your two answers are -4 and -7. But it's tricky because you're not expecting to see a quadratic, but there it is. So hopefully you've seen enough of those where it's not going to throw you off too much. But do remember, quadratics are going to show up, and it's important we factor those. All right, number 22. Number 22, we have 6 to the x power equals 99. Now, again, this is an exponential problem, right? So the exponential problems follow the 3 steps. Step 1 being to log both sides. I'm just going to write log both. You guys have seen that enough to know that it means log both sides. So I'm going to throw log on this side, 6 to the x, and then log on the right side, 99. And then step 2 is to move my exponents. So there's only an exponent here. I'm just going to move that to the front. So it's going to be x times the log 6 equal to the log 99. There's no exponent on the 99, so there's nothing to move there. Step 3 is to divide logs. Now, since log 6 is on the side with x, I'm going to divide by log 6 so that I can cancel it out. So that means x is equal to whatever the log 99 divided by log 6 is. So again, that's just a matter of typing that in the calculator. Log, not the natural log, regular log, 99, make sure you close your parenthesis, divided by log 6. And we get 2.56, we'll just round it to that, 2.56 as an answer there. Number 23. My chair is a little squeaky too, so if you hear that, I apologize. Number 23, we got log base 2 of x plus log base 2 3x plus 2 equal to 3. Now this one's a little different. I've got two logarithms. They're both base 2. I'm going to need to combine them into just one logarithm with that base. So to combine two logs that are being added together, I need to take these parts within them and multiply. So I have to do x times 3x plus 2. So it's kind of like a distributing thing. X times 3x will make 3x squared, and x times 2 makes 2x. So I'm just distributing. I'm combining these logs into one. They're both log base 2, so this is also going to be log base 2. But when I see this plus sign, that's my tell that I'm actually going to take these parts here and multiply them together. And that's what I get when I multiply them together. Now, don't forget this is still equal to 3. Now, this is very similar to number 19. I have a regular logarithm, just one plain logarithm. What I'm going to do now is I need to convert this into an exponential equation. So if I convert this into an exponential equation, I'll have 2 as the base of the exponent. 3 will be the exponent, so it would be 2 to the third power, equal to this main part of the log, which is a 3x squared plus 2x. Now, 2 to the third power is 8, so it's really 8 equal to 3x squared plus 2x. Now, I'm going to erase this so I have more room because I still have to work this out. So, excuse me for clearing the screen here, but what is this, 23, right? So we have 8 equal to 3x squared plus 2x. Now what we're going to need, because this is going to be a quadratic, is I'm going to move the 8 to the other side. So I'm going to subtract 8 on both sides so that I have 0 equal to 3x squared plus 2x minus 8. Now this quadratic I need to solve. So we would factor it again in the calculator, and I believe, I forget what the factors are. I believe we get, I think we get x plus 2 and 3x minus 4. That might be That should be right. So remember, this is equal to 0, so you still have to solve for x. If you have x plus 2 equal to 0, then that means x is equal to negative 2. And if you have 3x minus 4 equal to 0, then that means divided by 3, we get x equal to 4/3. So I have two answers, negative 2 and 4/3. But I need to plug these in to make sure that they work. So we're going to remember these numbers, negative 2 and 4/3. Because I'm going to go to my calculator and I need to type these in. Now be careful, because remember, it's a log base 2 in the problem. So if you look at the original equation, right, it's a log base 2 of x. So I'm going to type in, I got to go to the math key, and I'm going to go find my log base function. So that's that one. Make sure I plug in the base of 2, because if you don't remember to do that, then obviously you're not using the right version of log and it's going to be wrong. Let's plug the negative 2 in first for x. So, well, actually, let me put x in here just so, I'm not going to keep it there, but I'm just going to show you guys to make sure you understand where I'm coming from. Log base 2 again. So another one of these, 2, and then it was 3x plus 2, right? So, oh crap. I don't know what I did there, but we're all good. 3x plus 2. But of course, I'm going to be plugging in a number for x. So I'm going to plug in the negative 2 in this one. And I'm going to plug in negative 2 here. Now be careful, because I want to make sure that I'm doing 3 times negative 2. So I'm going to put parentheses, negative 2 there, close parentheses, and then don't forget that plus 2 that got erased from there. So that's the equation that we started with. But where x was, I plugged in negative 2. And when I hit enter, I'm expecting to see the answer to be 3, because on my paper it says it's 3. And it's not working, right? So negative 2 doesn't seem to work. And that's okay. That's totally fine. But now let's take this and let's plug in our other number we got, which was 4/3. Now be careful when you type in 4/3. When I do it, I like to just keep it, 4 divided by 3, because it, that's technically 4/3. But be careful when you type it in over here. Make sure it's in its own set of parentheses. So 4 divided by, let me just insert it, 3. So you can see that the 4/3 is in its own set of parentheses there, so that it can be multiplied with the 3. You've got like an outer set of parentheses that wraps around the 3 and the 2, and then you've got like an inside set of parentheses for the 4/3 specifically. So everything should be typed in this way. You got it. We're going to hit enter. We're going to expect to see the number 3. So we got the number 3. So 4/3 is an answer to this one. Negative 2 is not. So just 4/3 would be the correct answer. Let's look at number 24. Number 24, we have 5 to the x equals 175. This is very similar to number 22. So if you got 22, you should be able to do this. It's another exponential equation, so we're going to follow the 3 steps. You've already seen the steps, so I'm not going to write them down again, but follow those 3 steps. We're going to log both sides. So log 5 to the x equal to log 175. Step 2 is to move the exponent. The only exponent I have is that x, so I'm going to move it to the front of the log. So we have x times the log of 5. There is no exponent on the right side. It's just log 175 still. And then since the log 5 is being multiplied to x, I'm going to divide by the log 5 to make sure I cancel. So that will leave me, if that all cancels, that's just going to be x on the left equal to whatever this number is. Log 175 divided by log 5. So log 175 divided by, oops, I gotta make sure I close that parenthesis, divided by log 5. We get 3.2. 3.21 if you really want to round to 2 decimal places. Number 25. So number 25 is, these are just simplifying. So these are actually pretty straightforward. Natural log e to negative 5x. So whenever you see natural log and e combined like this, there's actually 2 ways to see it. Natural log and e like this, or e to a natural log power. If you see either of these, they immediately cancel out. So of course we see natural log of e right here, so that means they're going to cancel out. So your answer is just plain and simple, negative 5x. Number 26, we have e 3 natural log of x, and this is an exponent. Now the thing is, the e to the natural log power will cancel. However, there's that 3 in the middle there. So just focus your attention on this for a minute. 3 times the natural log of x. I'm going to like zoom into that, okay? So whenever you have a number being multiplied to the front of a log, it got there somehow. It came from, and you need to remember this because I'm going to say it over and over again, but always the number that's being multiplied to the log originally came from the exponent spot. So this used to be the natural log of x to the third power, but that 3 got moved to the front. But what we need to do is we're going to just move that 3 back up to the top. We're going to move that 3 back into an exponent place. So it's going to be e natural log to the x to the third power. Now, since the 3 is not in the way, the e, the natural log cancel. So your answer is just going to be plain and simple, x to the third power. Number 27, we have natural log e x minus 4. It's very similar to number 25 because the natural log and e are just going to straight cancel. And just leave x minus 4 as your answer. Number 28 is very similar to number 26. We have e 2 natural log 2x minus 5. Same thing, we have 2 times the natural log. So that 2 got there because it used to be an exponent. So if you put that 2 back in that place, that exponent place, 2x minus 5 to the second power, right, putting that 2 over here again, then the e and natural log can cancel out. So your answer is just 2x minus 5 to the second power. So please remember that exponent switch. All right, number 29. Number 29, I have the natural log of 2x minus 3 equals 14. So now we're intruding on a whole different set of problems, the natural log problems and e problems. So you have to remember that e is the opposite of natural log, and natural log is the opposite of e. So I see a natural log. My instinct is I want to cancel the natural log out. All right. So again, what's the opposite of natural log? E. Now, if I'm going to put e in this equation to cancel out my natural log, it's kind of funny because if I use e, it stands for exponent, right? So that's going to mean that all this stuff becomes an exponent on top of e. It'll be e to the natural log 2x minus 3 power. Like all of this is the exponent now, and e is the base. If we do that to the left side, we have to do it to the right side as well. So the right side is going to be e to the 14th power. So it's the same equation, right? But now it's got e as that base. And now, well, what happens is the e natural log right here will just cancel out. So it's just going to be 2x minus 3 equals e to the 14th power. So now you just kind of solve it like a regular equation. E to the 14th power is just a number. It's a really, really big number, but it's still a number at the end of the day. I'm just going to leave it as e to the 14th because it's going to be better than writing whatever massive number it ends up being. So I'm just going to leave it like that. So if I'm solving this, I need to get the x by itself. So the first thing I'm going to do is add 3 so I can cancel that out. So that's going to be 2x equals e to the 14th power plus 3. Because I can't combine that 3 with the e to the 14th, so I'm going to leave it like that. So that's just adding it to the other side. And then I'm going to divide by 2. So if I divide the left side by 2, I have to divide the right side by 2. And that leaves us with x equal to e to the 14th power plus 3, all divided by 2. And yes, you can leave your answer like that. It is a number, but I'm happy just to leave it as the e to the 14th because that's just good. But remember how you use e in the beginning of this problem. You see natural log, you want to cancel out natural log, but to do so you use e. And when you use e, it makes all that stuff an exponent. So try to keep that in mind. Number 30. Number 30, we have e to the x minus 8 power minus 15 equals negative 4. Now, I know you're tempted to sort of try to cancel that e out. But, and we'll get there, but this negative 15 is kind of on its own, and I know that I can combine it with -4 because they're both just numbers. I can just combine those two terms. So just like a regular equation, if I want to, let's say, move or get rid of the -15 or the -15 here, I can just add 15 to get rid of it. But of course, if I do that to the left, I do it to the right. So it leaves me e to the x minus 8 power equal to 11, because -4 plus 15 is 11. So that was just combining these numbers together. So move the 15 to the right side so I can combine it, and together they make 11. Now, since e, there's nothing else, right? I'm not adding anything else on that side or anything. It's just e with its exponent. Now I want to cancel out e so I can deal with that exponent. So the opposite of e is natural log. So I'm going to put natural log on the side with e. And of course, if I put the natural log on this side, I have to put the natural log on the other side as well. I'm going to put that in parentheses. It doesn't have to be, but I'm going to keep it in parentheses. So that means the natural log and e cancel. So it's just going to be x minus 8 is equal to the natural log of 11. So again, if you want the x by itself, all you have to do is add the 8 to both sides so that you can have that x by itself. And this ends up being just a natural log of 11 plus 8. Now you can't combine those because they're not really like terms. Natural log of 11 is a natural log. 8 is just 8. So they're kind of independent things. You would just leave your answer like this. You can type in the calculator if you want to get an actual number, or you can leave it like that. But just don't try to combine the 11 with the 8 is all I ask. You can't do that. You'd have to leave it like this. Okay? Number 31. Number 31, we have the natural log of 6x minus 7 equal to the natural log of 4x plus 5. This is almost identical to number 21. So you have a plain log on the left, a plain log on the right, no other funny business going on. So that must mean that this log on the left is equal to this log on the right, which must mean that whatever's inside this log must be the same as whatever's inside this log. So if that's the natural log of 12, then this also has to equal the natural log of 12. So what I'm getting at is that 6x minus 7 has to be equivalent to the 4x plus 5. They have to be equal. Essentially, the natural logs are both kind of useless here. So you just have a regular equation, and you can just solve this equation. I'm going to move my x terms to combine my x terms. That gets me 2x minus 7 equals 5. And I think you guys can solve it from there. I think you get, at the end of that, if you show all your work, I believe x equals 6. Number 32, in the last really tricky problem. Number 32, we have 15 plus 9 e to the x equals 42. So again, you gotta have to treat this like a normal problem until you get to the e. So just like in number 30, we have a kind of an extra 15 here. I can combine the 15 with the 42 if I move the 15 to the other side. So that's what I'm going to do. I'm going to subtract 15 so I can just get rid of it over here. Just put it on the other side. So we have 9 e to the x equals 42 minus 15, which is 27. All right, now I have 9 times e to the x. Well, again, I just want to solve for x. So let's get rid of this 9 so that I can deal with the e in the next step. So to get rid of multiplying by 9, I can just divide by 9, and that will mean the 9 will go away. So dividing by 9, the 9's cancel. It's just e to the x equals 3, since 27 divided by 9 is 3. Now I can focus on the e, right? Now I can cancel out e. The opposite of e is natural log, so I just do natural log on both sides. Natural log on the left side will cancel out. Put natural log on the right side. And so that leaves you with just x by itself on the left. X is equal to that natural log of 3. Which again is a number, but you can just leave your answer like that, and that's probably good enough. Number 33. Number 33, Corey invests all his graduation money, which is $2,800, in an account that is compounded continuously. If he is getting a 6.2% return on his money, how much will Corey have after 45 years? So the word compounded, or the phrase compounded continuously, tells us the formula A equals P e to the RT power. So that's exactly what we're going to use. A is going to be our answer, so that's what we're going to try and find. P stands for principal, which is our starting amount. And now in this case, Corey is starting with $2,800 in his bank account or his savings account, whatever. E, remember, E is just E. E is just a number. We'll type that in the calculator. R is rate. Now, this account is going 6.2%. So remember, that's a percent, so you have to move the decimal twice. When you skip a second here, that void, you have to fill that void in with a 0. So the rate is 0.062, and then times T. T is going to be time in years. So Corey's leaving his money in the bank for 45 years. Must be some sort of retirement savings or something. So there it is. That's just plugging in 3 numbers. We plugged in the principal, the rate, and the time. And now we're ready to just plug this in the calculator and get a value for it. So we go to our calculator, we plug in 2,800. And then E, you have to hit second, and then the natural log button, which is by 4. You get the E, and now you can type in the exponent, which was 0.062 times 45. If you can type it in correctly, we should get the right answer, which is $45,586.86 if you want to round up. So there's your answer for number 33. And now number 34 is very similar. So number 34, same idea, got the same formula. Our answer, our principal, what we're starting with, Sarah invests $4,500. So we're starting with $4,500. E again is E. Our rate is 3.9%, but again, you have to move that decimal twice. So you skip a space, that means you have to fill it in with a 0, so it'll be 0.039 times T. Sarah's leaving it in the account for 5 years. So we'll just type that in the calculator, and we should have our answer. So 4,500. Again, to hit E, it's second, and then natural log button, that's our E. 0.039 times 5. There you go. That's going to be it for part 2. I hope it helps. If you still have questions, just shoot me a message on Remind. I'll try to respond to you as quickly as I can. Otherwise, good luck on the test, guys. All right, bye.